Hello, let's start studying our next topic. Our next topic is vectors. And as our first point to consider, let's define what a vector is. Well, a vector is a quantity that has a magnitude and a direction or sense. And normally this vector is represented by an arrow, like this one with a normal. Sometimes we have a little point on the starting point and the tip with a point right on the edge. All the length of the arrow, this length A, represent the magnitude. Length represent the magnitude or the modulus, and this little point here, this represent the sense. So we have, for example, we have speed, and we can say that we have speed of 40 meters per second. So 40 meters is considered as a scalar because is the quantity that represents a magnitude, but there is no direction or sense in this number. But if we say that there is 40 meters toward the OXXO store, then you have a magnitude and a direction or sense and the way that you are moving and how much is that length in terms of numbers. So the point represents the sense or direction, the length represents the magnitude or the scalar, and this length of magnitude is represented by this notation, is simply with a little arrow on the top, and this vector is going to be described or written between these two vertical bars. And every time you see this symbol here that represents that A between these bars represent the magnitude or the modulus of the vector. And some notebooks, they don't show this little thing, this little line in the top of the A. They show only in a capital bold font between the vertical lines, and this is considered the same as this. So you will see in some textbooks the bold font style between the bars, and in some other textbooks you will see regular character with a little arrow on the top. So this both represents the same. Okay, so The way that we compute things with vectors is by a coordinate system. So if we are using two-dimensional vectors, we will use this Cartesian plane. And when we were working with three-dimensional spaces, we will use the octant that we consider in our very last lecture. Okay, so let's start with some basic calculations. Let's imagine that we have a vector. This is vector A. Let's have this as vector A. And the coordinates for the starting and ending point for this vector A is 1, 3 and 4, 5. So please note that I'm writing these values for the coordinates in the parentheses because these notations represents a single point in the Cartesian plane. So we have here a point located at 1, 3, which is 1, 1, 3, 1, 3. This is the first point, and the ending point at 4, 5, which is this right here. This is 4, 5. So these two points is the starting and the end and the ending point of this vector. And let's start working with this vector. So this the next definition is how do we calculate the components of a vector. Okay, so the components of a vector, in this case the vector A, uh, equals x2 minus x1, y2 minus y1 in this case because we have only two-dimensional coordinate systems, and the notation for the components of a vector will be these arrow brackets. And please do not confuse this with this because with this notation we are describing only a location of a point in a coordinate system, and with these arrow brackets we are describing specifically the components of a vector. So the components for vector A in this case is 4 minus 3, that gives us 4 minus 3, no, 4 minus 1, that gives us 3. So that's the first component, and 5 minus 3 is 2. So this in the x-axis, the first component of a vector is the amount of distance that we move specifically in the x-axis. So it starts at 4 and ends at 1. So this distance here, the absolute distance in the x-axis is going to be 3 because here for 1, 2, 3. So this is the first component of a vector, and the second component of a vector is 5 minus 3, which is specifically the distance between the ending and the starting point of a vector, and the distance between these two equals 2. So this is the second component and the first component. So please don't forget that this is the way that we calculate the components on and determine vector. So in a two-dimensional space, we will represent the components of a vector like this. And in a three-dimensional space, the components of a vector will be represented like this: A1, A2, A3. So we will have this ordered triple, and the numbers A sub 1, A sub 2, and A sub 3 will be components of vector A. Okay, so please don't forget, and please don't confuse the uh, point or coordinate location notation with this component notation. So another thing to remember that we are going to use in our two and three dimensional coordinate systems is this is the component notation, but we have another notation, which is the standard basis vector notation. In Spanish, this is base canónica, ¿sí? Or vector unitario. Okay, I'm including the Spanish definitions because in English the base canónica is translated into standard basis. So to explain this, let's say that x is equal to I, y is the same as j, and z is the same as k. But I equals 1, j equals 1, and k equals 1. Okay, so if you have the components of a vector in this notation, let's say for example the 3 comma 2, this is only I and j, and we have this uh, numbers here which represents the distance on each one of the axes. So if we want to represent this vector in this standard basis, vector A will be written as follows: 3 times I plus 2 times j. Okay, so this is 3 times the standard basis I plus, because there we have a plus here, 2 times the j axis, which is the y-axis. So these two are the same, but this is represented in a standard basis, vectorial form, and this is in a component um, notation. So each one of these are the same, but this is showing that how much or how many units in I or in X axis we are going to move, and how many or how much in the Y direction. Or if we have a vector, let's say for example that we have another vector B, and this vector B has the components 2, 6, 8. Then if we want to write this vector in the standard basis vectorial notation, it will be 2I plus 6j plus 8k, and this equals this vector. Okay, so we will be working with both notations in our exercises, so please take note of this. we're going to switch from this component notation to the standard basis notation, so we can get familiar with both, because some of your future exercises will be written in these both notations, and we need to get familiar with this. Uh, okay, so in this case, let's say that this will be the I direction, and this will be the J direction, and this will be the K direction. And remember, please, always I equals 1, J equals 1, and K equals 1. So it's 2 times Y, 2 times I, 6 times J, 8 times K. And this is the way that we can uh, calculate or represent the vectors. Okay, so let's move to our next topic, and let's do some vector representation in this three-dimensional coordinate system.